So one of the key things about the inner product is that once we have the inner product, we have a notion of orthogonality. We say that the vector u is orthogonal to the vector v in some inner product space if the inner product between them is just equal to 0. And then in this case, we write u is orthogonal to v, or sometimes people read this as u perp v. Perp for that little perpendicular symbol. So then we have a theorem, and this one is like theorem 6.12, but it's actually a bit stronger, so I'll give it a plus. The idea is that u is orthogonal to v for every element of the inner product space if and only if u is the 0 vector. So u is orthogonal to everything, and u is the only thing orthogonal to itself. And if you have something that's orthogonal to everything, it can only be 0. Okay, and the proof is more or less dead simple. So for the forward direction, now of course, having said that it's dead simple, watch me screw it up. But from the forward direction, let's see. So if we're assuming that u is orthogonal to everything, then we know in particular that u is orthogonal to itself, right? So the inner product of u and u is equal to 0. But then if you go back to the definition, this is the definition of definiteness. There's a bad pun waiting to be made there, but I'm not going to do it. Okay, so that's done. That's immediate. In reverse, let's see. For any, if we take anything in V and we inner product it with 0, so here this is the vector 0. Then this is the same thing by vector space arithmetic as u times v. And so now in this one, we've got that u is a scalar, so it's the scalar multiple of the vector v by the scalar u 0. And then this is by homogeneity 0 inner product of v with itself. So that's by homogeneity. And then we've got 0 times a scalar is always 0. And that's by field axioms. And the end, we're done. Okay, so I told you, it was dead simple. And now it seems like this idea of orthogonality might be sort of not especially useful, because it's kind of an on or off property, like things have to line up just right for it to be true. But it turns out to be surprisingly useful in many, many contexts. You can do a lot of geometry just with orthogonality and without having to worry about like particular values of angles.